All right, so today we're going to work with multiplying and dividing radical expressions. Our learning targets: multiply and divide radical expressions and rationalize the denominator of a radical expression. All right, so tomorrow we are going to review activity 20 and take a short quiz over activity 20. So, starting with 1, it says complete the table below and simplify the radical expressions in the 3rd and 5th columns. So here, we want to take the square root of A times the square root of B. So what's the square root of A? I mean 4. So we have square root of 4 times square root of 9. That equals 2 times 3, which equals 6, right? What is 4 times 9? And the square root of 36? 6. All right. I would like for you to do the next two, and we'll get 2 people to come up and write their answers. All right, so what's going on here? So we have square root of A, so square root of 100 times the square root of B. Our B is 25, so square root of 100 times square root of 25. Well, what is the square root of 100? It is 10. What is the square root of 25? 5. So now we have 10 times 5, which is 50. All right, so in this column, we have A times B. A is 100, B is 25, so we have 100 times 25, which is 2,500. So now we're going to take the square root of 2,500, and when you enter that into your calculator, you get 50. So then for the last one, we're going to do the same thing. So square root of A, square root of 9 is 3. The square root of 16 is 4. 3 times 4 is 12. So then in this column, we have 9 times 16, which is 124. 140? 144. So then if we take the square root of 144, we get 12. 144 equals 12. Yeah. All right. So what are we noticing about these numbers? They end up the same. So we have 50, 50, we have 12, and 12. So using the patterns you observe in the table, write an equation that relates the square root of A, square root of B, and the square root of AB. So just take a minute to kind of ponder what it's thinking, what it's asking, and write your answer as an equation. Pattern. How can we write what we observe up here as an equation? That's it, yeah. So what we got for this column equals this column, and so we can just make the statement that they are equal. All right, so all of the values of A and B in part A are perfect squares. In the table below, choose some values for a and b that are not perfect squares and use a calculator to show that the equation you wrote in part B is true for those numbers as well. So we're gonna just pick some numbers and then two of you will put yours up there. All right. So let's look at letter D, simplify the products in column A and B. So we have we have 2 times the square root of 4 times the square root of 9, simplest form. So with this one, we have 2 times, what's the square root of 4? 2. So this first column becomes 2 times 2, which is 4. And then the square root of 9 is...
The athletic trainer is here. Thank you.
So 4 times 3 is 12. Our other option is that we can take our square root of 4 and square root of 9, since they're both square roots. We can combine them. And so we have 2 square root of 4 times 9. What's 4 times 9? And the square root of 36? 6. So 2 times 6 is 12. Alright, so now this only works, I should note, we can only go from square root of 4 square root of 9 to square root of 4 times 1 if the root index is the same. So these are both square roots, so that means they both have an index of 2. If we had the square root of 4 times the cube root of something, we can't combine them because they're not like best friends. They kind of like each other. They have things in common. They're both radical, but they're not gonna like move in together and become roommates or anything. They don't have that much in common. Just some things. They're not enough to be roommates together. All right. So let's take a minute, solve the next 2, and then we'll go over them. Let's bring YouTube into the loop. So here we have 3 times the square root of 4, which is 6. And then 5 times the square root of 16. So 5 times 4 is 20. So 6 times 20 is 120. Do the same thing over here. We're taking our coefficients, 3 and 5, and multiplying those together. And square root of 4 times 16, which is... What's 4 times 16? 64. So then 15 times the square root of 64, which is 8, which is 120. And then Ellie's was a little more difficult because these are not perfect squares, so you need your calculator to do this first part, so you get decimals here. And then you get 59.38. And then for the second part, 2 times 3, we get 6. And then 7 times 14, we get, is that 98? And then we put that into the calculator to get the same thing. Alright, so looking at this, which ones are rational, which ones are irrational? So this first one, is that a rational or irrational answer? Rational, right? Because it can be written as a fraction. 3/12 over 1. Tom's, is that rational or irrational? Rational, right? Because we can write it as a fraction. Allie's, is this rational or irrational? Irrational. Alright. So write a verbal rule that explains how to multiply radical expressions. Here is the property. So we have we have a times the square root of b times c times the square root of d. You take the numbers in front of the radicals, you multiply those together, and then the numbers inside the radicals you put inside. So we could read it as ac times the square root of bd. And this will work as long as b and d are greater than or equal to 0. We'll get into what happens if you have a negative inside the square root later, but right now you know your calculator does not like that, and it gives you an error message, right? Alright, so let's look at this first example. Multiply each expression and simplify. So just like we've been doing, so we have 3 times the square root of 6 times 4 times the square root of 5. We take our numbers, multiply them together, in front. So 3 times 4 gives us our 12. And then 6 and 5, neither one of those is a perfect square. So we're going to put them inside our square root. We get 30. Does 30 factor any further? All right, so we're not going to get, so it's 2 times 3 times 5, right? Would be the factor tree. And so there's no perfect squares inside. Let's come down and do one together. The screen froze, so we'll stop. So looking at, we're not going to stop. I'm going to move to the sideboard. All right, so looking at